What if I told you you don't need more data to build better AI? In fact, some of the most powerful AI systems today learn from data that doesn't even exist. It's called data augmentation, and once you understand it, you'll never look at datasets the same way again. The problem: data is expensive. AI thrives on data, but real-world data is expensive, time-consuming to collect, sometimes impossible. Example: self-driving cars need millions of scenarios. Medical imaging, limited labeled scans. So the question becomes, what if we could create more data without collecting it? What is data augmentation? Simple definition. Data augmentation is creating new training data by slightly modifying existing data. Core idea: keep the meaning, change the representation. Example: rotate a cat image, still a cat. Flip, still a cat. Add noise, still recognizable. Key insight: we're not changing the truth, we're expanding the perspective. Types of data augmentation: image augmentation, rotation, flipping, cropping, brightness/contrast changes, noise injection. Example: one image, 20 variations. Model learns robustness. Text augmentation, harder than images. Methods: synonym replacement, back translation, random insertion and deletion. Example: AI is powerful. Artificial intelligence is powerful. Audio augmentation. Add background noise. Change pitch. Speed variation. Use case: voice assistants trained for real-world environments. Tabular data augmentation. SMOTE. Synthetic minority oversampling. Noise injection. Feature permutation. Example: fraud detection. Rare cases boosted. The technical intuition. Why it works. Key concept: generalization. Without augmentation, model memorizes. With augmentation, model learns patterns. Analogy: imagine learning to recognize a face only from one angle. You'd fail in real life. Augmentation, showing multiple angles. Overfitting versus generalization. Overfitting, memorization. Augmentation forces flexibility. Slight technical depth. Augmentation increases data distribution diversity, helps approximate real-world variability. In simple terms, you're teaching your model to expect the unexpected. Advanced augmentation. Generative augmentation. Generative adversarial networks. Diffusion models. Example: generate synthetic faces. Create medical images. Mix up and cut mix. Combine two images and labels. Concept: model learns blended representations. Real-world use cases: healthcare, rare diseases, autonomous driving, edge cases, retail, product recognition. Pitfalls: too much augmentation leads to noise. Unrealistic transformations. Label mismatch. More data isn't always better. Better data is better. Data augmentation is one of the simplest ways to dramatically improve AI without collecting a single new data point. So the next time you think your dataset is too small, ask yourself, have you really used it fully?